Day 786 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again. Another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1846, maximum element after decreasing and rearranging. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. You are given an array of positive integers R. Perform some operations, possibly none, on R so that it satisfies these conditions. The value of the first element in R must be 1. The absolute difference between any two adjacent elements must be less than or equal to 1. In other words, the absolute value of R of I minus R of I minus 1 must be less than or equal to 1 for each I where 1 is less than or equal to I and I is less than R dot length in a zero indexed array. The absolute value of X is the absolute value of X, or ABS parentheses X is the absolute value of X. There are two types of operations that you can perform any number of times. Decrease the value of any element of R to a smaller positive integer. Rearrange the elements of R to be in any order. Return the maximum possible value of an element in R after performing the operations to satisfy the conditions. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So, in example 1, we have our input R equals an array of integers 2, 2, 1, 2, 1. The output is 2. Explanation says we can satisfy the conditions by rearranging R so it becomes 1, 2, 2, 2, 1. The largest element in R is 2. So, let's break this down one step further, y'all, right? Because remember, one of the requirements is the value of the first element has to be 1. And we're allowed to rearrange the elements of R in any order. So right here, you can see right now, the first element is not 1. So we need to rearrange it. After we rearrange it, now it starts with 1. And then we need to also satisfy this condition where any two, the absolute difference between any two adjacent elements cannot be greater than 1. So as you can see, this has a difference of 1, this has a difference of 0, 0, or excuse me, this has a difference of 0, this has a difference of 1. As you can see, none of them have a difference greater than 1, so that's what we want. So if it's that requirement as well. So now that once we have this and it fits the requirement, 2 is the maximum or the greatest element in this array, right? There's no other element in this array greater than 2, so that's why we return 2, because we want the maximum possible value. Now, let's take a look at example 2, where we may have to use our the second operation right here and decrease the value, because up here you might think, well, we didn't have to do anything. We can just see that the greatest or the maximum value is 2, so we can return 2. But you need to remember that this array was already set up so that the no two adjacent elements had a difference greater than 1, whereas right here they have elements where the difference may be greater than 1. So let's see how they solved it. So in example 2, our input R equals an array of integers 100, 1, 1000. The output is 3. You might be wondering, how do we get 3 from this input, right? So it says, one possible way to satisfy the conditions is by doing the following. So first, we're going to rearrange R so it becomes 1, 100, 1000. Because remember, it must start with 1, right? That's one of the requirements. The first element of R must be 1. So we're going to sort it so it starts with 1. Boom. Then we're going to decrease the value of the second element to 2. So then this 100 becomes 2, because remember, we are allowed to decrease the value of any element to a smaller positive integer. And since we can only, the difference has to be less than or equal to 1, or the absolute difference has to be less than or equal to 1, we're just going to change this to 2. Boom. Then we're going to decrease the value of the third element to 3. Once again, the absolute difference between the two adjacent elements has to be no greater, or has to be less than or equal to 1. So we need, if this is 1 and this is 2, then the only option is we could change this to 1, 2, or 3. We're going to change this to a 3, and now our array will be an array of integers 1, 2, and 3. Now, after we change this array, after we perform these operations, and we're left with this, well, let me just come over here, right? Boom, so y'all can see. So first operation, we're going to decrease this to 2. Next operation, we're going to decrease this to 3. Boom. After we perform those operations, 3 is the greatest element, so that's why we return 3. Boom. Now, just in case that didn't make sense, let's take a look at example 3. So in example 3, our input R equals an array of integers 1, 2, 3, 4, and 5. Our output is 5. Explanation says the array already satisfies the conditions and the largest element is 5. So as you can see, this array already satisfies the conditions because the elements, no two adjacent elements have an absolute difference greater than 1. And that's all we really need. It starts with 1. Sorry, that's another requirement. It must start with 1. So it fits both of the requirements already. And since it already fits the requirements, we could just find the greatest element. And in this case, the largest element is 5. So we return 5, y'all. So boom, I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now, first thing we're going to do is we're going to sort the array so we can greedily build the largest valid sequence from left to right. So we're just going to come right here, and we are going to say let sorted R equal R dot sorted, and put a parentheses. Boom. Now, after rearranging and decrementing elements, the first element can always be made equal to 1. So we're going to track the largest valid value that can appear at the current position while satisfying these conditions. But for now, we could just declare a variable called current max, and we'll set that equal to 1. Now we need to process the remaining elements in sorted order. So we're going to say for I in 1 dot dot less than sorted R dot count. We're going to open up the brackets, and then the next value can be at most current max plus 1. Otherwise, the difference must be the previous element might exceed 1. It also cannot exceed its original value because we are only allowed to decrement elements, not increase them. So therefore, the best value we can assign here is going to be the minimum of the current max plus 1 and sorted of Ri. So we're just going to come right here, and we are going to say current max equals min, open up the parentheses, current max plus 1, comma, sorted R, square bracket I. Boom, y'all. And after processing every element, the current max represents the largest possible value that can appear in the final valid array. So we just need to come right here, and we can say return current max, y'all. Boom, that's all she wrote. Let's give it a run. Make sure it runs properly before we submit it. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. And look at that, y'all. 0 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see, y'all. So with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.